Hello, in this video we're going to go through another one of these variable acceleration, variable force questions. There's loads of questions like this, but it's worth practicing them, particularly getting your maths up to speed. So let's draw our picture as we're going along. It's another one of these parachute ones. We've got a parachutist of mass 72 kilograms, so weight of 72 g. Opens his parachute at time t equals 0, speed 30. Okay, we don't need that yet. Air resistance force of 240 V newtons, so it's a function of the speed. So we've got this variable acceleration going on. I'll draw the acceleration going downwards, but again, that isn't exactly critical. Now we have to do our usual thing. This is F equals ma. They're trying to scare you a little bit, maybe by putting the acceleration as dv dt, but we do the usual Newton's second law, and we'll say that we've got 72g minus 240v is equal to 72 dv dt. Now we just got to rearrange things and get rid of some numbers to make it look like what they've given us in the question. So the key thing to look at here is what's going on with v. We've just got a straight v there, so we're going to need to get rid of this minus 240. So if we do that, everything's fine. So let's divide by minus 240, which is going to give us v minus 3/10 of g is going to be equal to minus 3/10 of dv dt. So sticking in your value for g, then that's going to come out fine for what we need on this 2.94. So yeah, they've made it quite handy with the 72, dividing out nicely with a 240. So yeah, 3/10 of 9.81. Are they going to be using 9.81 or are they just using 9.8? Doesn't really matter, because we'd have 9.81, so divide that down, 0.98 multiplied by 3, so that would come out at 2.94. So we don't need the 1 there, 9.81, but still we've got exactly what they want in the question, so that's the main thing. I don't know what they use on this particular exam board for their value of g, but they could have just rounded it a little bit. Now we have to find v in terms of t, i.e. solve this differential equation. Same old thing that we've got going on here. When you've got the some quantity that's varying with time that is proportional to that quantity itself, we know we're going to get exponentials coming out of all of this. But let's rearrange things. We're going to have to treat this left-hand side as one term, because otherwise we're not going to be able to get the v's over with the dv's. So let's just have, what should we have, minus 10 over 3 integral of dt is equal to the integral of dv divided by v minus 2.94. Of course, this 10 over 3 bit you could have sitting anywhere, really, it doesn't matter too much. Now let's put in our limits. Time is going from 0 to t. Velocity starts at 30 and goes to some velocity v. So let's put all of this in. We've got minus 10t over 3 is going to be equal to, this is going to be our log thing going on here. So we'll have natural log, and we're going to be subtracting two logs from each other. So v minus 2.94 divided by 30 minus 2.94, which is 27.06. Now we're just going through the final few steps. So we will have v is equal to 2.94, just rearranging to make v the subject, plus 27.06 multiplied by e to the minus 10t over 3. So a nice simple rearrangement to do at the end. And that solved our differential equation. Now they just want us to sketch this. So again, this is making sure that your maths is up to scratch. We want to be able to sketch exponential graphs. So we're just doing v against t. We know that it starts at 30. I'm a little bit squished in here. But yeah, it starts at 30. And then what's going on as t increases? As t increases, this thing here, which is a denominator of a fraction, is just getting bigger and bigger. So this second term, as t increases, so as t tends to infinity, this term here tends to 0. So we got an asymptote at 2.94. That's what we're tending towards as t goes to infinity. So it's going to be smoothly coming down to this asymptote where that value there is 2.94 meters per second. So again, same old thing. We've only applied really one physics idea here of Newton's second law. I know we've drawn a force diagram as well, but most of this work is in maths. Most of it is our calculus and then sketching a graph. So as I always say, if you're going to be a physicist, make sure your algebra, your calculus, and in this case graph sketching and all this other stuff in your maths is up to scratch, because otherwise you ain't going to get very far.